Hi everyone, this video is about geometric sequence focusing on finding an nth term or an unknown term with the given first few terms or previous term which is not the first term and r. In a geometric sequence a sub 1, a sub 1r, a sub 1r squared, a sub 1r cubed, and so on, the nth term is a sub n equals a sub 1 r raised to n minus 1. You can use this formula or general rule if the first term is given. Okay, a sub n is the nth term. N, of course, refers to the position of a term. A sub 1 is the first term. R is the common ratio. Now, what if the first term is not given? Instead, a previous term, not the first term, and R are given, and you're going to look for an unknown term. So in a geometric sequence, a sub k and r are given. The nth term is a sub n equals a sub k r raised to n minus k, where a sub n is the nth term, n refers to the position of a term, a sub k is the kth term or the previous term, r is the common ratio, and k is the position of that previous term. Let's have an example. Example number 1. Find the 12th term of the geometric sequence 4, 16, 64, and so on. Let us make a list of all the given. First term or a sub 1 is 4. R is equal to 4. Now recall how to find the common ratio. Just get the ratio or the quotient of two consecutive terms backwards. That is 16 is to 4 is 4, or 16 divided by 4 is 4. 64 divided by 16 or 64 is to 16 is 4. N is 12 because we're looking for the 12th term. Then let's look for a sub 12. By using the nth term, a sub n equals a sub 1 r raised to n minus 1. We have a sub 12 equals 4 times 4 raised to 12 minus 1, where n is 12, first term is 4, r is 4. Performing the operation, we have a sub 12 equals 4 times 4 raised to 11. Therefore, a sub 12 is 16,777,216. Example number 2. Find the 10th term of the geometric sequence negative 80, 40, negative 20, and so on. The given are first term negative 80, r is negative 1/2, n is 10. What is a sub 10? So we will be using the first rule or first formula wherein a sub 1 is given. That is a sub n equals a sub 1 r raised to n minus 1. Substituting the given, a sub 10 equals negative 80 times negative 1/2 raised to 10 minus 1. N is 10, a sub 1 is negative 80, r is negative 1/2. Performing the operation, now recall the law of exponent. Video related to that is available in this channel. Now, a sub 10 equals negative 80 times negative 1 raised to 9 over negative 2 raised to 9 is a sub 10 equals negative 80 times negative 1 over 512. If a base is negative and its exponent is odd number, the resulting sign is negative. Let us continue. A sub 10 equals, we have negative 80 times 1 over 512. So that is positive 80 over 512. If the resulting term can be rather converted into lowest term, so you have to give your final answer in lowest term. Okay, so therefore a sub 10 is 5 over 32. Example number 3. Find the 9th term of the geometric sequence 1/6, 1/2, 3/2, and so on. The given are a sub 1 is 1/6, r is 1/3. Recall how to find r, that is divide or find the ratio of two consecutive terms backwards. So in here, the given terms are fraction, so you need to apply the cross multiplication to get the common ratio. Continuing, n is 9 because we're looking for the 9th term. What is a sub 9? A sub 1 is given, so the formula we will be using is the a sub n equals a sub 1 r raised to n minus 1. We have a sub 9 equals 1/6 times 3 raised to 9 minus 1. A sub 9, a sub 1 is 1/6, r is 3, n is 9. So continuing, a sub 9 equals 1/6 times r is 3 raised to 8 is 6,561. So performing the operation, 1 times 65 or 6,561 divided by 6 is equal to 2,187 over 2. Another example, number 4. Find the 22nd term of the geometric sequence c raised to 10, d raised to 2, dc raised to 9, c raised to 8, and so on. Recall the law of exponents. Okay, to perform operations on algebraic expressions. Available, the video related to that is available in this channel. Given R, a sub 1 is c raised to 10 d squared. R is 1 over cd, n is 22. What is a sub 22? A sub 1 is given, so we will be using the first rule. A sub n equals a sub 1, r raised to n minus 1, that is a sub 22 equals c raised to 10 d squared times 1 over cd raised to 22 minus 1. So a sub n is a sub 22, a sub 1 is c raised to 10 d squared, r is 1 over cd, n is 22. So proceeding, we have a sub 22 equals c raised to 10 d raised to 2 times, that is, the exponent is 22 minus 1, so that is 21. So recall your law of exponents. So 1 raised to 21 over cd raised to 21. So we have c, or a sub 22 equals c raised to 10 d squared times 1 equals 1 over, c raised to 21 d raised to 21 is a sub 12 equals c raised to 10 d squared over c raised to 21 d raised to 21. Applying the law of exponents, same base and division, subtract their exponents. We have 1 over c raised to 21 minus 10 d raised to 21 minus 2. Therefore, a sub 12 is 1 over c raised to 11 d raised to 19. Another example, number 5. Find the 17th term of geometric sequence a sub 3 equals negative 20 and r is negative 1/2. This time, the given is not the first term. So let us list down the given. A sub 3 is negative 20, r is 1/2, n is 17. What is a sub 17? Use the second formula. A sub n equals a sub k, r raised to n minus k, where a sub n is a sub 17, a sub k is a sub 3, r is negative 1/2, n is 17, k is 3. So continuing, a sub 17 equals negative 20 times negative 1 raised to 14 over negative 2 raised to 14. Recall the law of exponents. A sub 17 equals negative 20 times 1 over 16,384. A sub 17 equals negative 20 over 16,384. Its lowest term is negative 5 over 4,096. Example number 6. Find the 13th term of the geometric sequence a sub 6 equals 81 and r is negative 3. The given r, a sub 6 is 81, r is negative 3, n is 13. What is a sub 13? Use formula number 2 because a sub 1 is not given. So we have a sub n equals a sub k r raised to n minus k. That is a sub 13 equals 81. Quantity negative 3 raised to 13 minus 6. A sub k is 81. That is a sub 6. R is negative 3. K is 6. Then a sub 13 equals 81 times negative 3 raised to 13 or 7 rather. So a sub 13 equals 81 times negative 2,187. Therefore, a sub 13 is negative 177,147. Alright, so that's it. I hope you've learned something from this. More videos about geometric sequence and law of exponents and operations on algebraic expressions are available in this channel. Bye!